All right, so we are on to we're on to lesson 1-4 today.
You want to sit down with me?
We're looking at comparing numbers now. And we should know, we've been doing lots of comparing, that when we compare, we're using things like greater than and less than signs. And they've shown us what those symbols look like right here. The greater than symbol has the bigger side open on the left. And then the less than symbol has the small side on the left, because we read from left to right. So as we're looking at that symbol, we see the greater side first for greater than, and the less than side first for less than. So just some simple comparing. 27 is greater than 72, right? I'm sorry, 27 is less than 72. And then 10 is greater than 3 plus 4, because what is 3 plus 4? It's 7, and 10 is greater than 7. So we've got the greater than sign there. But we have been dealing with fractions. So we're going to learn some different tips and tricks that we can use when comparing fractions today. The first thing that we're going to look at is fractions that have the same denominator. Go ahead and unmute yourselves. Tell me, where is the denominator in a fraction? Is it on top or is it on the bottom? Which
On the bottom. Bottom.
The bottom, yes. Denominator is on the bottom. Thank you. If two unit fractions have the same denominator, then they're made from the same unit fractions. I'm sorry, if two fractions have the same denominator, they're made from the same unit fractions. So those fractions are all the same size pieces, right? So if we're comparing 3/5 and 4/5, my fifths, whether they're in the 3/5 or in the 4/5, they're all the same size pieces. So if my denominators, the bottom number is the same, I can just forget about those and just compare by looking at the top number. So when I look at the top, I know that 3 is smaller than 4. So that means that 3/5 is going to be less than 4/5. Okay. So just off to the side, do me a favor and compare, let's say 2/7 and 5/7. You can unmute yourselves. Tell me which fraction is greater. Which fraction is greater?
5/7.
5/7 is greater. So it would go like that. They have the same denominator, but they have different numerators. 5 is bigger than 2. So 5/7 is going to be larger. What if I had, let's say 7/9 and 6/9? Unmute yourselves. Which one's greater?
7/9.
7/9 is greater because 7 is bigger than 6. Okay, so that's what we can do when they have the same denominator. That only works when the denominator is the same, when the bottom number is the same. If the denominators are not the same, then the unit fraction sizes are different. So that philosophy will not work. Okay, sometimes we have the same numerator. Which number is the numerator, the top or the bottom?
Bottom.
Yes, the numerator is on top. So if they have the same numerator, then the number of unit fractions is the same, but the size of the pieces are different, right? So if I have 2/5 and 2/7 that I'm comparing, which unit fraction is bigger? Is 1/7 bigger or is 1/5 bigger?
1/5.
1/5 is bigger because remember, we have that, they're the same size whole, but we're cutting it into fewer pieces. So each piece is going to be bigger. Think about it like your birthday cake, okay? If you have your birthday cake, would you rather cut it into 4 pieces or into 8 pieces?
4.
Probably 4, because then you're going to get a bigger piece of cake, right? So it's kind of a little backwards when you think of it, because the one with the smaller denominator is actually the larger fraction. The smaller denominator is the larger fraction when they have the same numerator. So 2/5 is greater than 2/7. Okay, same numerators, we look at the denominators, and the smaller denominator is the bigger fraction because the pieces are bigger. So what if I gave you 3/4 and 3/7? Which one's going to be greater?
3/4.
3/4. 3/4 is going to be greater, right? And that one's almost one whole. This one's not even to a half yet. 3/4 is greater. You're right. What if, oh, I'm going to get tricky on you guys here. I'm going to say 143 over 172 or 143 over 251. Look at those fractions. Which one is the bigger fraction?
143 over
What? 1,004 billion.
143 over 172 is bigger because the pieces that we're cutting are bigger pieces. Yes, excellent. Does that make sense? So
Yes.
if it's the same denominator, the bigger numerator is bigger. If it's the same numerator, the smaller denominator is bigger. And guess what, guys? You guys have this book with you at home. So when you're working on your homework, what should you have out next to you helping you?
This math
This
book.
book. Yes, book. All right, so there's some practice problems down here. Take a minute and go ahead and try these 6 problems. Go ahead and try these 6 problems.
You know what, I will try.
You cut out for me right there.
I will try. I will try. I'll try. I'll try. I'll try.
I'm going to kind of talk my way through them as I do them. So if you're still a little unsure about this, follow me as I go, okay? So 4/9 and 4/7, those have the same numerator. So I know that if the numerators are the same, the smaller denominator is bigger. So I know that 4/7 is going to be greater than 4/9. 2/10 and 1/10 have the same denominator, the same number on the bottom. So the unit fractions are going to be the same size.
2/10.
So 2/10 is going to be bigger than 1/10. 1/5 and 1/3 have the same numerator. And when you have the same numerators, the smaller denominator is the bigger fraction. So 1/3 is going to be greater. 5/8 and 6/8, same size unit fractions because the denominators are the same. So 6 is going to be bigger than 5. 3/7 and 3/8, same numerators, denominators are different. When my denominators are different, the smaller denominator is my larger fraction. So 3/7 is larger than 3/8. And on the last one, I have 5/7 and 6/7. They have the same denominator, which means they're the same size unit fractions.
Is the big.
So 6/7 is going to be larger than 5/7. Okay. All right, let's keep moving. Now, that's all great and dandy when we have either the same numerator or the same denominator, but unfortunately, most of the time that's not going to happen. So you can't use those shortcuts. So we're going to look through some other strategies that you can use to solve unlike denominators. Can I have anybody just go ahead and unmute and just read this top part to us.
Case.
If two fractions have different denominators, you can compare them by first rewriting them as equivalent fractions with a common denominator. You can use different strategies to do this depending on how the denominators are related.
Good. So we've spent the past few days this week learning about equivalent fractions and how to write equivalent fractions. So now what we're going to be doing is we're going to be writing our fractions as equivalent fractions so that way they can have the same denominators. So in the first case is when one denominator is a factor of the other. So for example, I know that 4 can go into 8, right? This denominator can go into that denominator. So I can use my 8 as my common denominator. I just have to take my 3/4 and multiply the numerator and the denominator by the same thing to make it over 8. So when I would start this problem, I would have my 3/4, and I would put it's equal to something over 8. Because I know that 8 is what I want to have as my denominator. And I would think in my head, okay, 4 times what makes 8? 4 times 2.
2.
So if I'm multiplying the bottom by 2,
Yes,
I have to multiply the top by 2. So now I have 6/8. And now I have 6/8 and 5/8. And since they both have the same denominator, it makes it really simple to compare them, right? 6/8 is greater than 5/8. And remember, 6/8 is just another name for 3/4. They're the same thing. So 3/4 is greater than 5/8. Okay, that's one way. The second case, the only number that is a factor of both denominators is 1. So 5 can't go into 7. 7 can't go into 5, but I can multiply 5 times 7 and get 35 and make that my common denominator. But now I've got to set up my 2 fractions so I can find their equivalent fractions. So I would have 4/5, right? Because that's one that I started with. Is going to equal something over 35. Now I got to think, what's my multiplier? How do I get from 5 to 35? Times 7, right? 5 times 7 is 35. Well, if I multiply the bottom by 7, I have to multiply the top by 7. 4 times 7 gives me 28. I have to find my equivalent fraction for 5/7 also. 5/7, I want it equal to something over 35. My goal is to make these fractions so they have the same denominator. That's what I'm trying to do. How do I get from 7 to 35? Times 5. 5 times 5 is 25. Now I can compare 28/35 and 25/35. Okay. Stick with me, guys. Okay, because we're going to go through these and then I'm going to show you another way to even do it, which I know you're probably thinking, mind blown, but you're going to choose which way is easiest for you to do. I'm just giving you lots of options. Like when you walk into the ice cream store, they give you lots of options. You choose which ice cream is best for you. And on the last one is that there's a number besides 1 that's a factor of both denominators. So 9 and 6, I could do 9 times 6 and go up to 54, but that would make my fractions really big. So I could think, okay, what else do 9 and 6 go into? Well, I'm going to count by 9s. I know 6 can't go into 9. What comes next when I count by 9s? 18. Does 6 go into 18?
Yes.
Yes.
Yeah.
Yes, it does. So I'm going to set up my 2 new fractions. 7/9 equals something over 18. And 5/6 equals something over 18. And I'm going to find those equivalent fractions. All right, 9 times 2, 7 times 2, 14 18ths. 6 times 3, 5 times 3, 15 18ths. Now I can compare those two. Okay? So those are 3 other methods that you can use to find those common denominators. Now, I'm going to show you guys a shortcut right now. I'm not even going to keep going. Okay, I'm going to show you a shortcut that will work for these. Ready? Some of you might have learned this last year. If you had me, I think you did. Or you saw me teach it to the 5th graders. But I'm going to take this 3/4 and 5/8 right here. 3/4 and 5/8. And the way I'm going to compare them, pay attention, you're going to want to know this. Everybody looking closely?
You cross them over.
I'm going to take, and the diagonals, the ones that go across from each other, I'm going to multiply those. 5 times 4 is 20.
20.
8 times 3, because I'm multiplying my diagonals, is
24.
24. What's bigger, 20 or 24?
24.
24. So my sign's going to go that way. You guys see how I did that? I'm going to do it for 4/5 and 5/7. I'm going to take and I'm going to multiply 5 times 5. What's 5 times 5?
25.
25.
25. What's 4 times 7?
28. 28.
28. What's bigger, 28 or 25?
28.
28.
28, my sign goes that way. Let's do the next one. Did my screen freeze?
So,
Okay.
Yeah, you're frozen.
Okay. I know why, because my iPad is trying to shut down. Let me turn it back on here. There we go. 7 9ths and 5 6. I'm going to multiply diagonals. 9 times 5 is
45.
45. 7 times 6 is
42.
42. What's bigger, 45 or 42?
45.
45. You guys tell me, which way's easier?
Your way.
Probably the crossbow. I would love to say it's my way. It's not really my way. It's just another way I can show you guys. Okay, so I just want you guys to do 7, 8, 9. Don't worry about 10, 11, 12. Just do 7, 8, 9. You can choose whichever method you want.
Okay.
You can choose whichever method you want. I might do them in a couple different methods because some of them have some big numbers. So I'm going to kind of talk through as I work. And you guys, if you've got it, you can just work on your own. Okay. Camden, do you have questions, buddy? I hear you talking. All right. So 5 times 2, I know is 10. 7 times 1 is 7. I know that 10 is greater than 7, so my sign's going to go that way. This one, it's really big. I don't really want to do 18 times 5, so I might find an equivalent fraction because I know that 6 goes into 18 3 times. So I might set this one up as something over 18. And I know that 6 times 3 is 18, so 5 times 3 is 15. 15, 8, oh, these are equal. Those two are equal. And then this last one, I think I'm going to do the butterfly method again. 8 times 5 is 40. 12 times 3 is 36. Oh, 36 is less than 40, so my sign's going to go that way. Okay. We're not done yet. I hear a couple people chiming off. Don't leave. We've got a couple more pages to do still in here. Are we doing okay with this? All right, since I don't see any hands up, let's look at the next page. The next page talks about some special cases. And these are some other things you can look at when you're comparing your fractions. You can always compare them by finding that common denominator, by finding those equivalent fractions, okay? But in some special cases, you don't have to do that extra work. Like when we had the same numerator or the same denominator, we don't have to do the butterfly. We don't have to find a common denominator. We can just use our heads and look at it, okay? Here's a couple other special cases. We can look and see if the fractions are close to a half, because you could determine, well, which one's closer to 1/2. So, or which one's greater than 1/2 and which one's less than 1/2. So I'm comparing the fractions to 1/2. So 5/8. Is 5/8 bigger than 1/2 or less than 1/2?
Bigger.
It's greater than 1/2, right? If you think about your number line, 4/8 would be 1/2. So this one is greater than 1/2. How about 2/5? Is that greater than 1/2 or less than 1/2?
You're glitching.
That's less than 1/2. So 5/8 is going to be greater. Okay, because 5/8 is more than 1/2 and 2/5 is less than 1/2. What if both fractions are close to 1? So 5/6, see how that's only 1 unit away from 1? 6/7, same thing. That's only 1 unit away from 1. So on that, you can look at the size of the units. Which is a bigger unit, a 1/6 or a 1/7?
6.
A 6 is the bigger unit, right? Because there's fewer pieces. So it's going to be further away from 1, which also means it's going to then be the smaller fraction because it's farther away from 1 whole. 6/7 is closer to a whole because they're smaller units. It has less distance to go to get to 1 whole. Okay?
You're glitching. You were glitching.
Okay, it could be on my side. It could be on your side. Not
It's
sure.
not lagging for me.
Yeah,
It's
sorry I
on
had to leave, but like my screen was like going black, and then it would like go to you, and then it was like flashing back to black.
Okay. Well, so what I'm going to tell you guys is we've reached the end of the instruction part of this. The rest of the work that's in this book is just practice problems like we would do if you were at school. But since we're not at school, I'm not going to have you worry about finishing up through page 12. I'm going to have you do your practice in your homework book, okay? But like I said, don't put away your student activity book. Keep that with you so you can look at it to reference to help you answer the problems. So we have just some basic comparing and then some word problems down below. Let's take a quick look at the remembering side. We're adding fractions. We're finding those multipliers and divisors. And then some equivalent, yep, all review stuff, okay? So, give me just a second here.